Bowen to you all. One more beautiful time. We are in grade 10 science and we have been learning chemical basis of life. And this is as per the Sri Lankan government school syllabus, and we will talk about disaccharides today in this chapter 1, video number 5. Disaccharides it is. What we will learn today? Yes, what is disaccharides? We will understand that. And then after that, types of disaccharides also we will see. Let's get into the subject and see all those things. Welcoming you all to the session. Okay, two monosaccharides coming and joining together, and it is forming disaccharides. Therefore, mono is 1, di is 2. Two monosaccharides coming and joining together and forming disaccharides. Now you know how the disaccharides are getting formed. During this process of joining two monosaccharides, during this process a water molecule is released also. When two monosaccharides are joining, water molecule is releasing also. Can you reverse this action and get monosaccharides? Okay. Monosaccharides joining together and forming the disaccharide. Can you put that back and take two monosaccharides out of that? Yes, in the same way, relevant monosaccharides can be obtained by hydrolyzing disaccharides. How they can do? By hydrolyzing disaccharides, you can get that monosaccharide. Lovely. We already learned the monosaccharide, and monosaccharides got certain qualities, structural unit of carbohydrates, and it is simple sugar, and it got a shape crystal, and it is sweet and water soluble. Now disaccharides are sweet also, and it is water soluble, and it also crystals as well. So something very similar, the monosaccharides and disaccharides are sharing the same quality, sweet, water soluble, and crystal. We came to know that. So two monosaccharides are forming disaccharides and giving away water molecule. How we write that one in equation? Here it is 2C6H12O6. Yes, it can be reversible. That's the reason the arrow is like this. When you put an arrow just like this, it is reversible. C12H22O11 and plus H2O, that is water. By hydrolyzing disaccharides, you can get the monosaccharides back again. Monosaccharides got glucose, fructose and galactose. Does disaccharides also got examples like that? Maltose, sucrose and lactose. Those are the three things that disaccharides are known for. Maltose, sucrose and lactose. It's time for us to understand those examples one by one. Maltose. Where do you find maltose? Germinating seeds you find maltose. Maltose you can find in germinating seeds, and two glucose coming joined together and can form maltose while giving away water. So it's a very simple example. Glucose plus glucose will become what? Maltose and water. An intermediate product of starch hydrolysis. When you're eating this bread or macaroni or rice or any kind of oatmeals or any meals, which are starch by the way, to get that particular starch as glucose to get into the bloodstream, it should break. Now when it is breaking, in some way it will become maltose, right? And then only the maltose will become glucose. Then the glucose will get into the bloodstream. So the maltose is in between. So that's the reason they call it as intermediate product. Now, the second one is about sucrose. Where do you find sucrose? You find sucrose in white and brown sugar. You find sugar cane and beet the sucrose. You can find sucrose in some fruits, and finally phloem sapien trees. That's the reason the ants are crawling on this tree, because they found sucrose, they are on the tree and they can eat it. It's very sweet. Sucrose is sweet also. Right. So how the sucrose is made? Glucose joining together with fructose and it will make the sucrose. You understood that one. Glucose joining with fructose made sucrose. We came to know glucose together, another with glucose. It is joining maltose. It's produced and with water. Now glucose and fructose, when it is joining, the sucrose is made along with the water. Do we have anything called glucose and galactose joining together? We will understand that one. That is in front of you definitely. That is lactose. You find this lactose in the dairy product, and as we discussed, galactose joining with glucose, will form the maltose and the water is given away. So glucose plus glucose is maltose. Glucose, fructose, that is joining and it will become sucrose, and glucose and galactose form the maltose, and don't forget the water is also given away. So let's understand little more detail about lactose. It's interesting. The only sugar that is absent in plants is lactose. Every other sugar you can find in plants, but not lactose. Lactose you find in the dairy products. So it's not sweet as sucrose. Therefore, it is not sweet as sucrose. This is very interesting. The percentage of lactose in cow's milk according to the composition is 4 to 6%. The percentage of lactose in cow's milk according to the composition is 4 to 6, and the percentage of lactose in human milk according to the composition is 6 to 7. So the human got more lactose than the cow milk. We came to a very good knowledge about it. What did we learn? Okay, we learned what is disaccharides and types of disaccharides without any doubt. Let's put a little recap what we learned. Maltose, glucose and glucose joining together and it becoming maltose and the water, and it is there in the germinating seeds. And sucrose you find, yes, glucose and fructose together comes in sucrose and it is giving water away. You can find in the brown and white sugar cane and beet. And phloem sap in trees. Galactose and glucose joining together and forming maltose and giving away water. You find that one in dairy product. Sugar that is absent in plant is definitely lactose. It's not sweet as sucrose. We came to know that. There are two compositions that we understood. Cow's milk got 4 to 6% lactose and human milk got 6 to 7% lactose as composition. And that's all for this session. We understood really deeply about disaccharides, and I'm going to meet you to learn about polysaccharides in our next session. Until then, bye bye and take care of yourself.